Okay, look at this question as I'm discussing this question now. As you can see, Karen dropped a ball, right, from this height. Okay, so the question asks you, which of the following graphs shows the amount of gravitational force? So I want you to highlight this part, gravitational force, acting on the ball at these positions, P, Q, R, S. Okay, this question, some students are very careless because as you know, gravitational potential energy changes with height and mass, but the gravitational force do not change. Okay, the gravitational force do not change, right? Acting on the ball. So your answer should be what? Should be 1, right? The gravitational force. Okay. Next question. Okay, there's a piece of plasticine thrown against a wall as shown in this direction. Which of the following could have happened to the piece of plasticine? Okay, you see this plasticine is slightly deformed, right? So plasticine change in shape, and then it also change in direction, yes? Okay, the mass doesn't change. Okay, can you change this one? There's a typo error there. This one should be C because there's no D down there. So it's A and B. So answer 1 again. Okay. Okay, this question we put an asterisk here because through my teaching, many students get this answer wrong. Okay, we see why. Why many students get this answer wrong. Okay, these questions can be exploited. Exploited or expanded to the section B questions. Okay, you see here, at first, right, when P was added, you know, like a Lego stacking, right? They stack the thing. So the P was securely tied to the base, this part, the base block. And this one is, this part is dangling in the air. Okay, so you see when he added the third block R, okay, block Q and R, this one, fell to the ground. Okay, leaving P stuck there. P is still stuck there, but these two drop off. So they say which of the following is the reason why these two blocks drop. So whenever you answer this question, you must understand that these two blocks, right, they will have more mass, right? More mass will lead to more weight. Okay, so the weight of this Q and R exceeds the frictional force between P and Q. Okay, so can you see this friction between P and Q? Okay, friction between P and Q, right, is less than the weight of Q and R. So the answer is 2. Okay, is 2. Okay, so we take note of this. So why I say this can be expanded to a section B questions, because in section B, right, they may ask you, give your reason, okay, or explain why this happened. Okay, there's a similar questions in past year PSLE questions, maybe I've seen before. You know, when you charge your phone, right? Okay, you charge your phone, right? The phone has this part, right, where you connect to the cable. So they say at first the phone didn't drop. After some time, the phone dropped off from the cable. So it's the same concept. Okay, the mass of the phone exceeds the weight of the phone exceeds the frictional force between the cable and the charger. Okay, next question. Okay, this one is a flat surface. So which of the following correctly identify arrow of the type of forces acting? So gravitational force is acting downwards, right? And frictional force in the opposite direction. Okay, so gravitational force is in the direction of P. And so this answer is 3. Okay, no problem, right? Okay, you notice here, I put an additional question here, this part. Okay, when you do such question, I want you to highlight the axis. So you notice here, this is the extension of the spring. Okay, extension means how much longer the spring has extended from its original length. Okay, so when you see extension of spring, you must notice that it will always start from 0. Okay, so as the mass increases from 10 to 50, right, the extension increase in a linear way. Linear means proportionate way. So we do the first part first. The original length of the spring is 8 centimeters. So you take note of this. This is important information. 8 centimeter original. That's mean without any mass, the spring itself is 8 centimeters. So what is the length of the spring when a load of 20 gram was hung? So from here, you take a ruler, right? Okay, you draw the line here, and then you see this part. Okay, so it's 3, right? So this is extension, correct? So extension is 3, original length is 8. So the total length will be 8 plus 3. So answer is 4. Okay, now this is my additional question. So I ask, what mass will stretch the spring to a length of 14 centimeters? Okay, this one you need to have two-step thinking. Firstly, you ask yourself, to stretch to a length of 14 centimeter, how much extension do I need? So 14 subtract 8. So I need an extension of 6 centimeter, right? Correct? So from the graph there, can you see, you can circle this 6, then you draw a line across here, okay, and then you hit down, and this is the mass you need. So answer is 40 gram. Okay, so this answer is 40 gram. This is additional question. Okay, next question. So you have done this one already. I go on to the next set. Okay, next set is this part. Okay, this part. Next set. Okay. The diagram shows a boy to hit a ball in a table tennis game. Okay, he's playing maybe with somebody or against the wall. So which of the following can underline this word most likely happen when he hits the ball? Okay, so when he hits the ball, right, you play table tennis, of course the ball will change speed, right? You may change direction also, right? So this one won't, right? Increased mass won't, right? Gravitational acting on the ball also won't. As I told you, this part remain the same. So it's A and B again. Okay. Okay, this type of graphs, anyone afraid to see such graph? Now there are two graphs there. So there now is the length of spring. Okay. And then this is the mass hung. Okay. So they say the graph shows how the two spring X and Y changes when different amounts of mass are added to each spring. Okay, you notice here, length of spring. So at 0, okay, the spring must of certain length. So that means X actually is a shorter spring than Y from the beginning. Okay, X is this line, is shorter than Y. So this is the first thing you know. Okay, second thing I told my student who have attended my lesson before, you notice spring X, right? If you study mathematics, right, is steeper, right? Okay, steeper means the spring is more elastic. Okay, more elastic means for the same mass, right, spring X will extend more than spring Y. Okay, this is one trick. Okay, if you compare two spring, you see the gradient, the slope. The steeper gradient or the steeper slope, right, means that the spring is more elastic. Means that for the same mass, it will extend more. So which of the following statements are correct? Okay, gravitational force acting on spring X is less than that. So this one confirmed wrong. Because I told you gravitational force is fixed, correct? The original length of spring X is shorter, which I told you is correct, right? Spring S is less elastic, so wrong. Because I told you already, right? X is steeper, right? So X is more elastic, okay? So naturally, if you know that concept, right, this one you straight away eliminate. You'll save your time of thinking. Okay, then in this one, you need to work out mathematically. When a 30-gram mass is hung on both spring, the length of spring X is more than that of, okay, because you already know the elasticity, right? So I told you at 30, right? Okay, can you see at 30? The length of spring X is more than that of spring Y. So this is true also. So it's B and D, answer 4. Okay, B and D. Okay, next, flat surface again. Which of following makes it difficult, underline this one, for the box to be pushed across the floor? Okay, I want to make it harder. Okay, so I can, if you have greater mass, right? Okay, because here they didn't say increase or decrease. They say the mass of the box. So if you increase the mass, of course, you make it more difficult. But here they didn't say anything. Okay, so which of the following make it difficult for the box to be pushed across the floor. The pushing force acting on the box. This one also, they didn't say increase or decrease, right? You notice. And then friction between the box and the floor. So that means all these three factors affect this one, all these three factors. So answer is 4. Okay, because there's no indication of increase or decrease. So if you increase the mass, of the box, right, you make it more difficult. If you decrease the force, the pushing force, you also make it difficult. Okay, if you increase the friction between the box and the floor, that's when you change the surface of the box, or you change the surface of the floor, you will affect. So we put it at this one. Okay, all three factors will affect. Okay, there's another extra question here. So this one my student will know. State 2 non-contact forces. So non-contact is gravitational and magnetic force. Non-contact means they don't need to touch each other. Okay, gravitational and magnetic forces, these two. Okay, 2 marks. Okay, next one. The diagram shows a ball falling from a certain height. Okay, and this represents the direction. The ball is dropping down this way. Which direction shows the direction of gravity and friction? So gravity always acts downwards, right? So you see this one downwards. And okay, because it's falling this way down, so there's air resistance going up, right? Correct. Direction of friction, because friction is this air resistance going up. So gravity is C, so answer is 3. Okay, simple, right? Direction of friction. Okay, next one. Okay, David is this person, and Jack playing football. David plays the football on the ground and kick towards Jack. They kick here. And Jack shown he failed to catch the ball by only to manage to touch the ball as shown in diagram 2. Okay, they say, however, Jack failed to catch the football and he only managed to touch the football as shown. As in he do something like a reverse kick or something. Okay, so which of the following statement about the effects of forces on the ball caused David and Jack actions is likely correct? So David, he initiate a force, the ball will move, right? So a force caused a stationary object to move, correct? This part. Okay. Then how about him? Is it correct? You see this one? A force changed the speed of a moving object. A force changed the direction. A force stops a moving object. So which is the better choice? Okay, because he's kicking, right? So it doesn't force like this one. So this one is wrong. A force changed the speed of a moving object. Okay, let's please, okay, put the football. That's it, the football is not moving. So this one also wrong. Okay, let's check this one. The force changes the speed of, okay, because this ball is moving there, then he kicked. So this one is most likely to be correct. So again, it's 3. Same as this question, 3. So we have done this one. This one, and this one. Okay, 2 contact forces. There's one question here. 2 contact forces. So we have the frictional and elastic spring force. Elastic spring force. Okay, frictional. 2 contact forces, frictional and elastic spring force. 2 contact forces. So I've gone through the questions here. Okay, so you take note, today's highlight is this question, because this question actually came out in the section B, PSLE questions in a different format, appears in section B. Okay, and you also need to take note, gravitational force do not change according to the height. Okay, it's a gravitational potential energy. So take note of this. And the other thing you learned today is about the elasticity of spring, right? As I told you here, okay, a steeper slope will indicate the spring that is more elastic. Okay, and then the extra question which I told you here, I taught you how to calculate the extension and total length of the spring by this graph. So if you understand the application of this, you should be able to do all the graphs questions on the extension of spring or the length of spring. Okay, so I would stop the sharing and then come back for you to ask questions.